Hello, folks, and welcome to Science Talk. I am your host, Jim Massa. In this video segment, I want to discuss with you Alaska's changing environment as climate change due to global warming is taking hold in the Arctic. Now, January and February would seem no, because it's been unusually cold up here. And it's really interesting because when you look at the entire circumpolar north, the entire circumpolar north is a lot warmer than average, except for Alaska and the Yukon Territory. Lucky us. Basically, the way I assess it is due to an extremely high positive value for the Arctic Oscillation. And if you go back to my Arctic Oscillation video, a high positive usually means that there's an extremely tight polar vortex and that the cold is really concentrated, and then couple that with where the high pressure system is located, it's kind of sitting right over Alaska and the Yukon Territory. So we got lucky. And it's been very cold. Basically, it's been in the 30 to 40 below realm, except for a couple breaks here and there, but mostly 30 to 40 below realm since mid-December. That's like 2 months straight now. But we haven't seen the extreme cold of 60, 65 below, which, by the way, if it weren't for global warming and look at the values of the Arctic Oscillation such as they are, that's what we would be having right now. So, yeah, 30 to 40 below. Could be worse. But it's thanks to global warming that we're not in a total deep freeze. But you go through the rest of the circumpolar north, and they're much, much warmer. And to be honest, up until this winter, which is the coldest in 25 years here in Alaska, up until this winter, it's been much, much warmer. So this is one of those dip downs that you typically see in certain cycles. But there you have it. So, but what I want to discuss with you in this video segment is, as you can see right there in the title, Alaska's changing environment, documenting Alaska's physical and biological changes through observations. So let's see what we've got here. I'm going to move this. Shove that up there so I can scroll down. Okay, so what do we have here? Okay, some nice pictures there. All right. Summer 2019. Big forest fires. A lot of forest fires swept across Alaska. Now, forest fires is a fact of life up here, but this is bad. And there's been some really bad fires in recent years. For example, I think 2003 was a particularly bad fire. So we have Alaska's changing environment, documenting Alaska's physical and biological changes through observations. Heather McFarland put together this document. International Arctic Research Center, University of Alaska Fairbanks, where I used to work. Rick Toman, that name should be familiar to you, as he's a meteorologist, and this gentleman had provided to me a lot of the figures, along with Brian Brett Schneider, that I have used in my other presentations when I put together what's going on with the weather. And of course, Dr. John Walsh, super nice guy. He, along with his co-authors, Wang and Wu, basically wrote the paper that first identified the Arctic dipole. So anyway, there's a picture of fighting some forest fires. So there are your authors, Rick Toman, John Walsh, Heather McFarland put it together. Hayo Aiken, he now runs the International Arctic Research Center, and he's a whole bunch of other folks there. Uma Bhatt is a atmospheric scientist, really nice lady, and so all these other folks involved here. So what do we got here? Alaska has recently experienced profound environmental change related to extreme weather events and deviations from historical climate, sustained warmth, sea ice loss, coastal flooding, river flooding, major ecosystem changes have impacted the daily lives of Alaskans around the state. Just ask any Alaskan who rely on a subsistence lifestyle. You've got salmon literally cooking to death in the Kuskokwim River last year because the temperature of the water reached 72 degrees Fahrenheit. Alaskan river waters are lucky if they get into the 40s. And the fish was literally cooking. So there's some stuff going on. Temperatures have been consistently warmer than any time in the past century. This warming varies greatly across the state, with northern and western regions warming at twice the rate of southeastern Alaska. The growing season has increased substantially in most areas. Snow cover season has shortened. Precipitation overall has increased, and like temperature, the changes vary regionally. Alaska is a big place. I mean, take a look at a map comparing the size of Alaska to the lower 48, as we call it, and Alaska is basically half the damn size of the continental 48. The ocean around Alaska is now regularly warmer than any time in the past 150 years, affecting everything from algae to fisheries and human health. There's been a major documented change in the phytoplankton community in the Bering Sea. Used to be diatoms, which are cold water phytos. Now coccolithophorids. They prefer warmer waters. And as I stressed many times in my videos, when you think of the heat capacity of water, that is to be blunt, shitload of energy that the oceans have absorbed. Okay? Just as, overall, globally, the oceans are the warmest sea surface temperatures ever for 2019. We got the data for that now. Coastal flooding during the autumn season has occurred on the Bering Sea coast throughout history, but recent winters have brought record low ice, which in the past has served as a buffer to the Bering Sea storms. This has resulted in out-of-season flooding, along with chunks of real estate falling into the ocean because the coasts are having the shit battered out of them. So basically, over the next several pages, we're going to share with you what's been happening. Okay. And by the way, if you go to iarc.uaf.edu, you'll be able to find this information. Once again, www.iarc.uaf.edu. Okay. IARC stands for International Arctic Research Center. So the five warmest winters in Utqiagvik, that's what we also known as Point Barrow, the last 5 years. Warmest month statewide, July 2019. I did a video talking about that, where it hit 90 degrees for the first time ever in Anchorage. Flooding, Dalton Highway, 2 months, April, May 2015. Wildfire, 4 million acres burned in 5 weeks, June to July 2015. Earliest breakup, the Tanana River in 2019. Coastal flooding, Little Diomede, February 2018. Record low sea ice extent, Bering Sea, spring 2018 to 2019. Now, they did not include what's going on in the Chukchi Sea up here, but that's also been record low sea ice extent, and even just really forming really, really late in the season, a record lateness, you could say. Record heat, Northway, 92 degrees Fahrenheit, June 2019. Now, a little caveat. Fort Yukon, which is located on the Yukon River where the Yukon River reaches its most northern point, did supposedly record a temperature of 100 degrees back in the 30s. Never quite been verified, but there is that caveat. Be that as it may. Longest growing season, 155 days in Bethel. Record heat, there's that 90 degrees I talked about. Warmest month, Yakutat, which is right there, part of the southeast, July 2019, right? July 2019 was a hot month. Warmest year, Kodiak 2016. The Blob, a marine heat wave, basically very warm, unusually warm sea surface temperature waters, which will affect vertical mixing, it will affect photosynthesis, affect the food chain, etc. And then a drought for 3 years running, inclusive, right? 2017, 2018, 2019, Southeast Alaska. Southeast Alaska is known for getting pissed on. Always raining down there. Not lately. So, what do we have here? We have the International Arctic Research Center, IARC. We have ACCAP. You've seen me mention these folks before. Alaska Center for Climate Assessment and Policy. And yeah, there's that website. So, you can go to that website and go find some info. All right, big fire seasons, more frequent. So many factors in Alaska's environment are specific to certain times of year. Ice breakup of the big rivers. That means spring is usually around the corner. Wildfires are a summer issue. The season is lengthening. Costly coastal flooding along the Bering and Chukchi Seas has historically been something that happens in autumn, which usually means August. While powerful storms impacting maritime operations near the Aleutians and Gulf of Alaska occur any time of the year, the strongest storms nearly always happen in the fall and winter months, which would be remember, the ocean seasons lag typically 3 months behind what we think of as the seasons. So let's look at the fires here. Warmer springs, earlier snow melt had lengthened the wildfire season to the point in 2006 when Alaska's Interagency Fire Management Organization changed the start date from May 1st to April 1st. That was a whole month earlier. Wildfire seasons with more than 1 million acres, which are the red bar graphs here, have increased by 50% since 1990, compared to the basically 1950 to 1989, that 40-year period. Total acres burned each year. Look at the frequency since 1990. We had 1, 2, 3, 4, 5, 6, 7. And actually they're talking about 1 million acres. So that doesn't qualify, that doesn't qualify. So it's 1, 2, 3, 4, 5. Since 1990, 1, 2, 3, that doesn't qualify. 4, 5, 6, 7, 8, 9, 10. There's your doubling. And that looks like 2008. That was a particularly bad year. This is a bad year. This is like 2015 or something like that. That was a lot of fires. So this leads to dramatically more smoky days, which leads to health issues. As the frequency of fires burning more than 1 million acres, so has the frequency of smoky days, posing a significant health hazard. Prior to 2004, Fairbanks had only one summer in 57 in the previous half century when there were more than 3 weeks of significant smoke. Since 2004, it's occurred 5 times, including twice since 2014. Days per summer when visibility is restricted by smoke. So there you have a graph, 10, 20, 30, 40. And just look at what's going on here since like 2004 or so, right there. Look at that. And there's a picture of stuff burning. So what do we have over on this side? Storminess not increasing. Storminess related to the frequency, duration, and intensity of wind is one of the most important aspects of day-to-day weather for Alaskans, especially if you live in a coastal community. In and around Alaska, there's been a slight overall decline in autumn storminess, September through November. Unless you're up in the North Slope, then autumn is usually like August, September, over the past 40 years. Winter, December through February. That's dark winter, as we call it, when there's low light levels. We also have light winter, which includes late September, October, and then March, and then early April. And to be honest, winter can happen any time of the year. Typically, winters can last 8 to 10 months of the year up here. I have seen it snow here in June, a significant amount, and it actually persists for at least a day. I remember one year it snowed on summer solstice. That was rude. So the winter storminess has shown no clear trend since 1990. There has also been no detectable trend in the number of moderate and strong storms during the past 70 years over the Bering and Chukchi Seas, where sea ice has retreated. However, even without an increase in storms, coastal flooding and erosion in these waters are increasing due to the fact that the sea is remaining ice-free. So you're having more open water. The season length of open water is getting more. So in other words, open water is lasting longer and longer. And with that, not having a cap on the physical activities of the ocean, you're going to have more wave battering of the coast. So basically, when I was part of the sea ice team, what we found, general findings, that ice freezes up later in the year and it melts earlier in the year. Hence, open water lengthens. The thickness of the ice was decreasing. The frequency of multi-year ice that survives, a summer to make it into the next winter, was decreasing. The southern extent, how far south in the Arctic Ocean through the Bering Strait into the Bering Sea extended, that was decreasing as well. So as you can see from these graphs here, the blue line is the summer, autumn storm activity, and the gray is winter storm activity compared to the average, which is this horizontal dotted line. As you can see, it's really not much of a trend there. It would have a low R-square value. River breakup happening earlier. Alaskans have closely watched spring river ice breakup for millennia and for generations have monitored the timing of the breakup of the Tanana River at Nenana. Every year they have a lottery. For $2 per guess, you write down the day breakup happens and the time it happens. And depending on how many people enter, if you are correct and don't have to share it with your correct guess with other folks, you can make up, you can actually win up to like 20, 30 grand, seriously. I was actually using some models to try and predict, but I've always missed it by like 4 to 6 hours. That was like the best I came close to. Anyway, so 4 of the past 6 years have seen breakup earlier than all but 1 year prior to 1990. The earliest breakup in the history of the Nenana Ice Classic by 6 days was in 2019. So if you look here at this graph, you see that the trend, here are the dates, right? The trend is that it's earlier, so it's happening earlier and earlier. So the red dots are the 10 earliest and the blue dots are the 10 latest. So we had a late one in about 2016, 2015 or so, but there's 2019, really on the low end. But 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 10 earliest have occurred since 1990, basically. And 1, 2, 3, 4, 5, 6, 7. I don't see the other two. Let me count again. But you can see most of the latest breakup has occurred earlier. So that's what this is showing. Okay, temperature. Recent years have brought many temperature extremes to Alaska, including the warmest year, 2016, the warmest month, July 2019. And by the way, 2019 was the second warmest year, and it wasn't that far behind 2016, like 0.3 of a degree or something like that. And that's the average for the entire state. The warmest day, July 4, 2019, for Anchorage. Air temperatures in Alaska are rising twice as fast as in other parts of the U.S., and apart from sea ice, are the most obvious sign of change. Factors contributing to this warming include decreases in sea ice and snow cover, warming ocean, increasing greenhouse gases. Of course, there's considerable day-to-day, even year-to-year variability. That's called weather. Depending on average storm tracks, but these trends are unmistakable. So in other words, things are warming up on average over the long term. That's climate. Day-to-day variability is called weather. for folks for the climate deniers who can't get that concept straight in their heads. And now the issue when you have especially the open sea is that open sea absorbs energy. So instead, if you had ice there, the ice is albedo, reflects sun energy back into space. Now you have open water, the waters absorb that sun energy, don't reflect it back into space. And then even as the sun levels decrease, that latent heat energy in the water is released. You release that heat energy, and guess what? It contributes to warmer air temperatures. That's part of what's happening. Fewer very cold days. Okay, up until January of 2020, one of the most dramatic changes in interior and northern Alaska has been the decrease in the number of very cold days. This graphic shows that the typical number of days in Northway Alaska with low temperatures of minus 30 Fahrenheit or lower has fallen from more than 40 days prior to 1960 to less than 30 days in the past decade. This trend is represented at most interior Alaska locations, including Fairbanks. Okay, and that shows you the approximate location of Northway. It's right there on the border with Yukon. But the trend is unmistakable. It's decreasing. Okay? And by the way, as we speak, the temperatures are dramatically warming up. Looks like this high pressure system is finally being elbowed out of the way. And we're having some low pressure systems moving in from the southeast, which means it's going to bring Chinook winds. And we're now talking temperatures in the 20 to 30 above realm for this week. So we've gone from 40 below going up to, let's say, 20 above. That's a 60-degree swing. If we hit 30 above, 70-degree swing. That's like the difference between 20 to 90 or 30 to 100, right? Choose your range. Warmer temperatures. Annual average temperatures are widely used as a measure for long-term changes, and modern techniques allow reasonable estimates of temperatures over large areas back to the 1800s. Temperatures in and around Alaska have been rising since the 70s, with typical annual average statewide temperatures now 3 to 4 degrees Fahrenheit warmer than during the early and mid-20th century. Recent years have all been exceptionally warm. In fact, 4 of the past 5 years, 2014, 15, 16, and 18, were warmer than any year prior to 2014. Take a look at this graphic, okay? Again, the blue dots are the 10 coldest. No 10 coldest after 1980. 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 10 warmest since 1980. And you can see this trend is the definite uptick here, starting from 1980 or so. Definite uptick. Record highs outnumber the lows. Daily high and low temperature records are widely reported measures of extreme. Given a stable climate, no warming and cooling trend, we would expect fewer than 10% of both high and low daily temperature records. That's a statistical thing. Okay? So for the period 53 to 2018 to have been set during the past 5 years. Okay? However, since 2014, there have been 5 to 30 times more record highs set than record lows. Now, even with this cold stretch, we did set an interesting record. We set the lowest high temperature recorded for the month of January, 4 degrees Fahrenheit. Previous highest low temperature, got it backward. We set a record for the lowest high temperature ever recorded in January of 4 degrees. The previous lowest high temperature was 5 degrees. Oh, hope I got that. Hope that's clear for now. So basically, for the month of January, it didn't get any warmer than 4 above. That's basically what we're saying here. Now is a new lowest high record. So percent of record warm or cold daily temperatures since 53 that occurred in 2014 to 2018. And this is a listing, Anchorage, Utqiagvik, Bethel, Bettles, okay, Big Delta, Cold Bay, etc. So you can see all the towns here. Homer's out on the Alaska Peninsula. Nome, where the Iditarod ends up. Yakutat, that's southeast. Talkeetna is a little bit north of Anchorage. Sitka is southeast, and so on. And basically what you're seeing here is it's percent. Look at that. Everything's just warming up. And as always, as I state in all these videos, I do these kind of presentations, feel free to pause the video and study whatever the graphics happen to be on the screen. I'm sharing these guys for you guys to study and understand and learn the latest of what's happening, because what happens in the Arctic does not stay in the Arctic. It affects the entire planet. Now, you've probably seen some of these types of graphics before. Fall and winter is warmer than average. The 2014-2018 average temperature in most regions and seasons have been dramatically warmer than the average for 1981 to 2010. Exception is summer, where the past 5 years have been close to normal over much of the state. That's indicated by here. But with a warmer winter means a less severe winter. And warmer winters can lead to more snow because warmer air can hold more moisture. Now, if you look at Western Alaska, it's still a little warmer than usual. White is average. So white is basically no deviation. These regions here on the North Slope over here is basically a little cooler than an average, but still it's 0 to 1 degree below the average, so it's close to the average. Greatest warming in the west and the north and the west, right? North and the west. Okay. Nome is located right about there. This is Norton Sound. Temperatures are rising all across the state, but not uniformly. The changes are largest over northern and western Alaska. Another reason for that contributes to that is you have the Bering Sea and the Chukchi Sea and the Beaufort Sea, and they're staying open, i.e., ice cover is happening later and later, so that gives off its heat to help warm those regions. That's a big reason. Temperatures have risen least dramatically in southeast and the Aleutians. With seasonal snowpack changes, sea ice, and more indirect factors. Utqiagvik, that's Barrow, high temperatures, and I presented a lot of this stuff to you guys before. Abrupt change in air temperature due to loss of sea ice is nowhere more obvious than Utqiagvik, formerly called Barrow, during the month of October. Direct heating from the sun is weak during October, so the autumn air temperatures are controlled by the amount of open water. Prior to 2002, many Octobers had extensive ice throughout the entire month, or at least by late October, allowing for much lower temperatures. In recent years, open water remained late into fall, and air temperatures were consistently warmer relative to the past. And there you see the trend. Okay. That's a Brooks range shot. So this looks like an autumn shot, good looking at the vegetation. Very lovely. You can see there's a lot of moisture in the air. Cold, damp. Now we look at precipitation. More and more of it. The interior Alaska used to be classified as semi-arid. Not anymore. More runoff on the North Slope. So Alaska precipitation is increasing throughout the state. Even so, precipitation varies, as you expect, because Alaska is a big place. Very strongly influenced by the way air flows across the mountain ranges. The amount of water flowing in non-glacier-fed rivers is a useful indicator of annual precipitation. The non-glacial Kuparuk River on the North Slope has been monitored since the days of the Trans-Alaska Oil Pipeline construction, basically late 60s, early 70s. Since 2013, the Kuparuk River has experienced unprecedented high annual flow, indicating high, relative to the prior 40 years, snow and summer rains in the region. And they give the discharge in cubic meters per second. So 500,000, these are cubic meters per second. What's important to note is the clear upward trend here. So here's the annual precipitation trend. Basically, what this is telling us is that it's increasing. That's a lot. That's a lot. 17.2% more precipitation. Everywhere in the state, there's more precipitation, not less. Southeast Alaska is one of the wettest areas in the world. Okay. Below is the standardized precipitation index for the region. The values reached in 2017 to 2019 were the lowest rainfall on record. Okay, and let's see if this is Southeast. Okay, the 0.113 and 0.5, that's over in Yukon and BC. It's actually BC. Yukon is up here. So this drought contrasts with the prolonged wet period of the early 2000s. Partly for this reason, the impacts of the recent drought have been tremendous, despite longer dry periods in the past. Some reservoir levels are now too low to reliably run hydropower. So you can see that it has dropped down in here. It's still getting rain, it's just not as much of it, which then constitutes a drought. And of course, the snow and so on. Freezing rain. Oh, this is a doozer. Freezing rain can pose significant threats to safety and wildlife. During the last decade, the number of winters with freezing rain in Fairbanks more than doubled what was typical for the 70-year period from 30 to 2000. School day cancellations associated with freezing rain have also increased. In winters with heavy ice accumulation of vegetation, caribou die-offs have occurred because the animals are unable to access their food. Because things are warmer, the precipitation doesn't fall as snow; it falls as freezing rain, and then you have a skating rink on the ice on the roads. There was one time I went to teach on campus, and what was normally an 18-minute drive for me took me 45 minutes. Class was held, and then on the way home, I just said, "Screw this!" I just came home, and there's this one little hill which seems innocuous enough. I couldn't get up the damn thing. Now, we're not talking a steep grade or anything like that, just an incline that goes for like maybe a quarter of a mile or something like that. I was down, I have a standard. I was down in first gear. I put into four-wheel low, and I just barely made it up that incline. It came down to, I came close to having just grabbed my chains and throw the chains on the tires. I came close to doing that. And so I finally made it back to where I was living, and I just parked the truck, and I think this ain't freaking going anywhere for a while. It was dangerous. And we're getting more and more of that every year. You can see how getting so many freezing rain in recent times. Shrinking snow. Snowpack now develops about a week later in autumn and melts nearly 2 weeks earlier in the spring compared to just the late 1990s, just 20 years ago. So here's the snow. Basically, this is showing when it starts forming and when it starts melting. As you can see, it's kind of trapezoidal in effect, meaning that its snowpack is getting later in the year and it's going away earlier in the year. That's what this graph shows. Alaska now becomes 50% snow covered about a week later than the 90s. So this shorter snow season impacts a wide variety of activities, ranging from overland travel by snow machine. We don't call them snowmobiles, we call them snow machines. So I don't want to hear anyone saying snowmobiles. It's snow machines. Or dog sled. Road maintenance is also affected. The shorter snow season does not necessarily translate to less snowfall, as heavy snow events can occur in a compressed snow season. So basically, instead of getting like an inch or two here and there and just spread over time, what you usually get, you get 10 inches in a go. Bang, there. Now you got to shovel that shit. Okay. So, and also with warmer air temperatures, you expect more precipitation. The warmer air is going to hold more moisture, which means more precipitation. Shrinking snowfields in the Brooks Range. Right? You know, it's again everywhere you go, snowfields are shrinking. This is they talk about the gates of the Arctic, uh, gates of the Arctic National Park and Preserve. That's what this is here. That's the location there. Really gorgeous area up there. Now, here's the interesting thing. Since new snow is typically brighter than old snow, this suggests that fresh snow from the previous winter is not surviving the summer season, so the underlying dark, dirty snow is left exposed. Dark snow absorbs more sunlight, which means it absorbs the energy, it will melt. In fact, typically, there's the Hall Road, something called the Dalton Highway. We just call it the Hall Road, which brings supplies to the oil fields at Prudhoe Bay. Well, you have all the dirt from, it's gravel road. You got all the dirt, all the exhaust, all of the particulates, whatever, and it covers the snow. Usually what we find is that the snow right next to the road melts out a lot faster and a lot sooner because that soot and all that darkening absorbs the sun energy. Okay, here we go. Sea ice. This is kind of what I wanted to get to. Sea ice plays a profound role in the climate, environment, and economies of Alaska. The present sea ice significantly modulates regional temperatures. You can say the presence or non-presence. Temperatures and moisture determines the structure of the marine food web and shapes the kind of activities that people can or cannot do, from subsistence and travel to resource extraction and so forth. Now, what about the marine food web? What's that about? There's an interesting thing called ice edge effects. And where you have the ice forming, okay, let's go in the spring. In the springtime, when you have the sea ice and that melts there, that creates a little mini stratification, and then you get what's called ice edge blooms. Basically, the phytoplankton, because of the stratification and there's the nutrients there, they can quickly photosynthesize, and you get a little mini food web there. On the flip side of it, when the ice starts forming, you get the same thing, but from the other direction. So you have the vertical sinking, so you get the mixing in there, and it leaves you with a calm upper layer where the phytoplankton do one last gasp of photosynthesizing before the winter sets in, and you lose all the light levels. But basically, it's referring to ice edge effects. The extent, duration, and thickness of sea ice has changed significantly in the seas around Alaska. The changes have been most widespread in late summer, autumn. The average sea ice concentration in September of '88 is on the left and 2018 on the right. Okay, this is 1988. Here's the Beaufort Sea, here's the Chukchi. We got ice here. Looky here. And it was even less for 2019. Open water. This is open water. This absorbs sun energy. That warms up the North Slope. More large open water areas, as indicated by this graph. So we've seen an increase in duration of open water in the Chukchi and Beaufort Seas to the north and northwest of Alaska. In both seas now typically open water for 3 to 4 months. Days per year with greater than or equal to 50% open water in the Chukchi. We see a little bit of an increase, kind of flattening in recent years, but it's still increasing. But the Beaufort Sea is just continually to increase. Chukchi sea ice extent decline. Now you have seen, if you've seen my other videos discussing this situation, these graphs should look familiar to you. Sea ice extent in the Chukchi Sea has declined dramatically outside of winter in recent years, especially during late summer. Typical ice extent in summer is only 10% of what it was in the early 1980s, and the September Chukchi sea ice edge is now regularly hundreds of miles northwest of the Alaska coast. So we can see the drop-off here. So this is how many square kilometers of sea ice there is. And you can see it's just tanked. It's just tanked right down. That means there's more and more open water. Same thing for the Bering Sea ice extent. Communities in the Bering Sea region reported the sea ice quality has been changing, with little or no old ice. That's multi-year sea ice, ice that survives the summer to grow thicker for the next winter, and thinner ice than in the past. Excuse me. Data show that the extent of spring and autumn ice has been declining, but until recently has been no long-term trend in the winter and early season ice extent. However, in 2018, 2019, late winter ice coverage in the Alaska waters of the Bering Sea was far lower than any winter in the past 170 years. Again, square kilometers of sea ice in the Bering Sea. And look at that, just drop right down. Kind of steady, and then little swings here, and then bang, it's dropped down to some of its lowest. Then we can look at when the Beaufort and the Chukchi freeze up. It's happening later. Now, they do become ice covered during the winter, but there are always cracks and leads. However, leads are open water stretches where you can put a vessel in there, like an icebreaker. However, ice over is now happening. Ice over, when the sea becomes covered in ice, have an ice cap to it, is now happening significantly later in the fall than in the past decade. Now, keep in mind, in these reports, when you see the word significantly, that means a statistical significance. With recent years, generally 2 to 3 weeks later, 2 to 3 weeks later than was just 30 years ago. So you can see the dates here, right? It's just getting later and later, from like October 11 almost into November almost into December, getting later and later. Ah, yes, there we go. Nice little doggy team. Lead dogs. Dogs behind the lead dogs are called the wheel dogs. They help coordinate any maneuvers. And then, excuse me, lead dogs, swing dogs. Wheel dogs are the ones right in front of the sled. They're usually your strongest ones. They pull they kind of help get the bulk. There's a lot of weight usually in these sleds. They help get it moving. The swing dogs coordinate what the lead dogs do. And you see me talk about this, warm surface waters. Summer sea surface temperatures in Alaska waters have been much warmer, colored red, than average, colored white. During 2014 to 2018, especially along the West Coast, where surface waters were 4 to 11 degrees Fahrenheit warmer than average in the summer of 2019. And this warmth can be seen throughout the region, Gulf of Alaska, Bering, Chukchi, Beaufort Seas. The years 2015, 2016 coincided with the occurrence of the blob of exceptionally warm water in the North Pacific Ocean. This warmth has persisted and even become more extreme in the 2017-2019 period in association with the unprecedented loss of sea ice. The past 2 winters, 17-18, 18-19, have seen marine heat waves, quote unquote, in the Bering Sea. The heat content of the entire water column was greater in 2018 than ever recorded. The cold pool of water, usually near the bottom of the Bering Sea, disappeared during this time. This disappearance has major implications for the region, as the cold pool served as a barrier to northward migration of various species. The Bering Sea is typically about 50-55 meters deep, so it's not very deep, right? Because when you had ice ages, this was all landmass because the sea levels drop, and then you had Beringia, and you got the land bridge between Asia and North America. So the fact that you got warm water reaching all the way down to the bottom, to the benthics, that's significant. And that's part of the reason why we've seen the changeover from diatoms to coccolithophorids. And now we come to ocean acidification. Okay. CO2 plus water gives you carbonic acid. That decreases the pH. There you have it. Ocean acidification poses major risks to marine ecosystems. Risks especially high in polar regions because CO2 dissolves more readily in cold water. Remember, the solubility of gas increases with a decrease in water temperature. Trends towards acidification are detected north of Alaska in the Chukchi Sea and in the waters of the Canadian Arctic and Greenland Sea. This can threaten commercial fishing. It can also change the depth at which the lysocline occurs, which is, does calcium carbonate stay in solution or precipitate out? If you're an organism that uses calcium carbonate to make your shell, and you're living at a water depth where it's going to stay in solution, you can't make your shell. You are now vulnerable to being eaten. And we're finding that the lysocline is getting shallower and shallower. I did a video segment discussing that very thing. Please go check it out. And then we have algal blooms. Abnormally warm waters have other consequences, including earlier, more spread spring and summer algal blooms of Alaska waters. And that would be this turquoise and dark turquoise that you see in this image here. Algal blooms sometimes produce harmful toxins. In recent years, there have been increasing reports of harmful algal blooms linked to instances of human shellfish poisoning in the Gulf of Alaska. Now, it's not quite dinoflagellate, which is red tide, but it's a similar phenomenon. Algal toxins have been documented in both stranded and harvested marine mammals, as well as healthy and die-off seabirds. Still trying to get a handle on exactly the implications of what's going on. So, algal toxin detected in marine mammals or seabirds. That looks like supposed to be a walrus. Looks like some seals, what have you. Oh yeah, whale, dolphin, seal species, and walrus, and the light green is seal, sea lion, and you got your otter and some seabirds. But that's basically what they're saying. So that's something that's being studied. And now the permafrost. Permafrost is warming and thawing. Measurements of permafrost temperatures at depths of 30 to 65 feet, well below levels where the seasonal cycle is felt, show warming at essentially all monitoring sites in northern interior Alaska. What does that mean, where the seasonal cycle is felt? Usually the upper 1, maybe 2 meters, and especially during summer with the direct sun overhead, and nearly 24 hours of daylight, beating down the energy, the upper 1 to 2 meters may thaw out, what's called a seasonal thaw layer. They're measuring this stuff down to 30 to 65 feet. That's 10 to 20 meters, well below the seasonal thaw layer, and they're finding what? It's warming. That is extremely alarming because remember, as the permafrost warms and thaws, microbial actions kick in, and guess what gets released? Methane. We know how more potent a greenhouse gas methane is. So they're now, basically measuring permafrost temperature in degrees Fahrenheit at 65 feet. And the various colors are represented by these graphs here. So Galbraith Lake, which is just on the other side of Adigan Pass, so you're on the north side of the you're on the side of the north slope going toward the Arctic Ocean. So you're on the other side of the Brooks Range. That's this line here. This looks like Dead Horse. This looks like Healy, Golconda. That's Coldfoot. And then there's Dead Horse. Okay, and that's Franklin Buffs. No, it was Franklin Buffs. I had a little hard time. Excuse me, there's Coldfoot. Women can see the differences in colors better than men can. So I'm having a little problem telling the different colors apart. It looks like this is Utqiagvik. That would make sense. This would be Barrow. It would have the lowest temperature. Okay, so that's got to be Coldfoot. That has to be Franklin Buffs right there. And yeah, there's Fairbanks. Okay, there we go. But the point of it is the permafrost is warming. They've been monitoring what's going on at the Dead Horse and so on. In the interior, the warming rates are smaller because permafrost temperatures are already reaching the melting point of ice. The ice melts, the permafrost, the ground itself thaws. See, melting point of ice as the permafrost thaws. Permafrost is defined as permanently frozen ground. Well, it's the ground that's frozen, it's unfrozen, it's called thawing. There's no change in physical state. Ice is a solid. It melts, becomes liquid. That's a change in physical state. A lot of people make that mistake. They say permafrost is melting. No, no, no. It's thawing. It's like taking a meat out of the freezer. Right? You just thaw so you can cook it. It doesn't melt. Another measure of permafrost change is the depth of seasonal thaw, known as the active layer depth. And okay, Seward Peninsula. Seward Peninsula is down here. 33 inches in 2018, in contrast to small values of 24 inches in the early part of the decade. So it's reaching deeper. The large thaw depths in recent years are consistent with high air temperatures in recent years. And then loss of glacial ice. Do I really need to read this description? Look at the graph. A clear trend down. Now, what are these up? This is like snow building up and then it melts, right? So this is reflecting year-to-year seasonality. So when it goes up, that's a snow deposition from snow. Then it melts, but then more of it melts, and so on. So when you put the fresh snow on it, it's bright snow, going to reflect sun energy. So it serves as an insulation for the moment. But then when that melts, the older stuff below starts to also melt. And eventually, it's sort of like one step forward, two steps back. Eventually, you keep losing the material. And then the Golconda Glacier Retreat. That's in the eastern Alaska Range. This has been steadily documented for over 50 years. And what does it say? A picture says 1,000 words. There you go. There's the ice. And look how far this has retreated. The glacier has retreated and has thinned by almost 100 feet. In other words, it's 100 feet less thick. And now plants. Now, I'm not a botanist, so this is not something you hear me talk about. I'll talk about phytoplankton because I am an oceanographer, but land plants, that's not my area, so I don't really talk about that too much. But what's happening is as the permafrost thaws, plants that need a deeper root can now take hold. Whereas in the permafrost, plants that require deep roots cannot get a hold in the ground because it's just too shallow. That active layer is just too shallow. That's why you see the tundra vegetation and so forth. Well, what we're seeing is that as things warm up, there is a northward movement of flora because the active layer is getting deeper, allowing these plants to that require deeper roots to take hold, and then they move their range northward. And then if you have the riparian zones, which are areas associated with rivers and creeks and so forth, riparian zone, typically the ground around that is not permafrost laden. So that's why if you're out there in the tundra and you see off in the distance a line of tall willows, pretty much you're going to find a little creek there or maybe a small river. You're going to find some running water there. And if you need water, you go there. Well, we're now finding that the riparian zones are expanding from width to width, either side of the running water. So we see that happening. So we're seeing vegetation moving north. Okay, so less green is i.e. brown. I have to lock up. There we go. Growing degree days relate to the average daily temperature or location compared to a threshold below which a specific crop would not grow. Like peas won't grow below 40 degrees F. This value for a single day accumulates across an entire growing season and can be used to estimate which crops will reach maturity. Since 2014, the number of growing degree days have increased across Alaska. And again, you can look at the graphics. Now, this is a nasty thing. Spruce bark beetle. Major outbreak of spruce bark beetles have been spreading throughout south central Alaska. It's now making their way into interior Alaska. The cold is not the cold of winter in interior Alaska. There's been recent trends. It's not sufficient to kill the larvae. So as a result, the spark beetles are now making their way out of the anchorage, what's called the Matsu Bowl area, into interior Alaska, which would be on the other side of the Chugach Mountains. And that is, of course, starts killing the spruce trees. So small population of beetles are always present in spruce forests. Sudden increase in population are favored by a dry summer, which reduces the tree's capacity to produce sap, which is a defense. Longer, warmer summers also increase the repro capacity. Milder winters increase the survival rates of the larvae. And as you can see, the acres, that's this vertical number here, this is acre, you can see that shooting upwards, how many acres are being damaged by them over the last 4 years. Beluga whales migrate from the Bering to the Chukchi and Beaufort Sea during the summer, followed by a return to the Bering in the autumn. Data from beluga whales tagged show that comparing 98 to 2002, then 2007 to 12, beluga whales from Chukchi Sea population delayed fall migration by about 33 days, resulting in a prolonged presence in the Beaufort Sea correlated with significantly later sea ice freeze-up. And there's a nice photo of about 7 belugas. June and July 2019, thousands of salmon died as they migrated to the spawning grounds of Western Alaska. You heard me mention this earlier. Although the cause is not confirmed, the leading suspect is unusually warm water temperatures above the range that cause stress to adult salmon. What are some of the problems? Warmer waters means less dissolved oxygen. Salmonids, salmon, trout, so forth, require a high dissolved oxygen content, which is afforded by cold water. You increase the water temperature, DO levels drop, the salmon's basically asphyxiate. Heat stress. It can also greatly accelerate the metabolism, resulting in faster burning of stored energy. Now, keep in mind, when these guys are migrating to spawn, they're not eating. So they're going to basically burn out their energy before they can spawn. That will result in a reduced year class strength. Not to mention, parasites and fungus that can weaken the organisms will take hold. Chum salmon. For villages that have dog teams, they feed their dogs chum salmon. This is going to affect them having dogs, whether they can get enough food to feed the dogs. Again, feel free to pause and, if I'm going too fast here, feel free to pause and read what I have on here. And then we have the shrinking walrus habitat. Walruses use sea ice for molting, mating, nursing, and as a staging area to go get some food. Sea ice recedes. Female walrus and calves must either remain on sea ice in water too deep for feeding or come ashore where stampedes can happen. And with stampedes, the calves are often crushed to death. Walruses for the past decade have gathered on the shores of a barrier island near Point Lay. These haulouts are associated with declining sea ice. During summer 19, several thousand hauled out, making the earliest walrus haul out since they were first observed in 2007. Beaver colonization in the Arctic. North American beavers are migrating to Arctic tundra areas and altering the landscape of northwestern Alaska. Beavers have historically occupied forested regions, light orange. There's new evidence that beavers have moved from forest into tundra regions, dark orange, re-engineering everything. So they're moving. Right? They're moving. Okay, and there's a picture of the walruses on an ice floe. So what are humans doing all about this? Okay, well, climate adaptation planning is underway. Statewide, city, Alaska Native, right, all these basic places. So you got the Nome, Norton Bay, Shaktoolik, Anchorage, Oscarville, Pedro Bay, Port Hayden, Chugach, and so on. So a whole bunch of things being implemented. They want to, obviously get a good database going, and then shifting subsistence resources, environmental change, and so on. So I like this little graphic here, and it's basically showing by the month here, right? Starting in what is it, January for all the months here. So in the past, hard, freeze, safe ice travel, and so on. Then you get into April, ice is not safe, called rotten ice. Then you get into the breakup. Then you travel by four-wheeler and so on. Then you get the freeze up in late September, early October. And it tells you when you go winter moose hunting, fall moose hunting, and so on. All the events here. So if you look in the past now, it happened. You can see when those activities would take place. From late October into mid-April, for example. Now it's late November into this one here, mid-November to basically late March. So you can do the activities later in the year. You have to wait a little longer, and then you can't wait and you can't proceed in the activity for as long. So now when you look at what's happening, ice travel is less safe, and then the unsafe ice happens in mid-March. And then you get the freeze up. So you can see it kind of a synopsis of everything that's happening, that's going on, and how it affects human activities. And then we have various people from around the place making, some observations. I'm not going to read through all of these. I'll just leave this up here for a few moments here. So if you want to pause it and read it, go for it. Okay. Now we'll just go down so you can read this material down here. So when you take these, now a lot of people say, well, this is anecdotal, true, but then when you start putting a whole pile of anecdotal stuff together, then you start seeing a pattern, along with data collection, so on. But oftentimes it's, thanks to, the observation of folks on the ground that help scientists formulate the studies and the research. In other words, they allow the scientists to know which questions to ask and how to design the experiment. And then we got some, Ronnie Dmitrieff, Mickey Collins, and Misty Walsh. Okay, so a whole bunch of acknowledgments here. And Rick Toman. He's a busy guy, but he's a really cool guy. He does a lot. He's a meteorologist, so he puts together a lot of stuff, and he also expands it out to sea surface temperature and the sea ice, because there is the ocean atmosphere interface and linkage. Those two systems are linked together. So you now have oceanographers and meteorologists, atmospheric scientists all working together. And Rick is just nice enough to put all this stuff together. And of course, there's Brian Brett Schneider, okay, and so on. Uma Bhatt, she's associated with the GI, Geophysical Institute, and IARC. And John Walsh, he's basically the chief scientist of IARC. And so he's a really cool guy. So there you have it. Lengthy presentation, but this is all that's going on in Alaska. Kind of pulling together what I've been discussing in these various weather things so those were like weather events going on and how it related, what the weather was in September, how that related to the overall trend. Now this video pulls all the trends together. So this is now the changing climate presentation. So I hope you found this informative, and thank you for your time. Hey folks, this is Jim here with Science Talk. I wanted to give a shout out to Whitney Alex and her channel. Her channel is The Green Report. She basically covers headline news involving environmental and climate issues. So once again, it's The Green Report. Go check it out. She does some very nice presentations. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.